diagram below shows the archer is training for the archery competition. Given that the distance of archery and the board is 50 meter, the height of the archer is 100 meter, while the height of the board is 20 meter from the ground. The mass of the arrow is 0.54 kg and the archer used different angle at 40 degree and 35 degree to shoot the arrow. Determine A. The velocity of the arrow and the time taken. B. The maximum distance that the arrow can travel. C. Average impulse force. D. Magnitude of impulsive force exerted on the arrow. E. The kinetic energy of the arrow.
First, we are using angle 40. Mass of arrow is 0.54 kg. Okay, this is our free body diagram. The distance between the archer and board is 15 meter. Okay, first, based on the question, for question A, it determine the velocity of arrow and time taken. Okay. From this free body diagram, we are using concept projectile motion. Okay. First, we make it in x motion. For x motion, we know that v naught x equal to v cos 40. V cos 40 because the angle is between x and v. So, x equal to x naught plus v naught xt. From this equation, we can substitute all the information that I have given. X, we substitute 50 because the distance between the archer and board is 50. Equal to x naught 0 because at this point where the archer at rest, the x is 0, so we substitute 0 into x naught plus v naught xt. V naught xt we know v cos 40 and t we don't know, we should find the t. So from this we simplify, so we got t equal to 50 over v cos 40 and simplify again equal to 50 over 0.7660v. So we have two unknown, so we cannot find the answer yet. So we using y motion. Okay, for y motion, v naught y equal to v sin 40. V sin 40 because v and y is the angle is far away. Okay, so from the equation, kinematic equation, we know that y equal to y naught plus v naught yt minus 1 over 2 gt squared. Y, we substitute negative 20 because as we know the coordinate for board is 50 and 20. So the value for y is 20 and we put negative because the arrow fly from the archer into the board is downward. So we should put negative. So negative equal to 100. Y naught is 100 because at rest, the distance for the archer is 100 meter. Plus v naught yt, we know that v naught y is v sin 40. So we just substitute v naught y and t from the above x motion, we simplify, we got this. So we just substitute into t minus 1 over 2. As we know gravity is 9.1. So just put inside t and t squared. T squared just substitute from the x motion. So we got the fully equation. So just simplify, negative 20 equal to 100 plus 0.6428 v 50 times 50 over 0.766 for v minus 4.905 times 2500 over 0.5868 v squared. Okay, from this we can just eliminate the v. So after we divide and multiply, we got 41.9582 minus this value. So after that, when this value we move it to negative 20, we will get and divide with negative 4.905, we will get the 3.1090 equal to 2500 over 0.5868 v squared. Okay. And after that, we simplify the equation and finally we will get v equal to 11.3591 meter per square. Okay, we already get the velocity. So when we get the velocity, we can include it inside this equation. Just substitute the v value inside here. So we will get the time taken for the flight to achieve the target is 5.7464 seconds. Okay, for the second question, it asks us to determine maximum distance that the arrow can travel, which is s. So based on formula of kinematic we can say that Sx equal to S naught plus V naught xt. As we know, S naught is 0 because it's at horizontal. There is no, still at rest, there is no value, so it's 0 plus V naught xt. V naught we already find, and from this formula V naught x we got V cos 40, but we already substitute this value, the final value of V inside here, so we will get 11.3591 cos 40 times 5.7464, and finally we will get the answer for maximum distance, which is 50.0027 meter. Okay, the next question is average impulsive force. For this, we assume that t is 5 seconds. So this is our free body diagram for the impulsive force. Okay. The impulse generated by the weight of the arrow is very small compared to that generated by the force of the impact. Hence, it can be neglected. Okay, for this is the equation for impulsive force, which is mv1 plus summation of integral t2 t1 f dt equal to mv2. As we know, m of the arrow is 0.54, so we just substitute inside here, and at v1 it is at rest, which is the velocity at v1 is still 0. So then the summation of this f dt we get f average time with time, which is 5 based on our assume, equal to mv2. M is 0.54, and v2 we got from the previous question is 11.3591. So we substitute inside here into I and j direction using a vector. So we got 11.3591 cos 45 I plus 11.3591 sin 45 j. So we simplify, and this we will get 0, so no need to add it. So this is going to be f5 f average equal to 4.3373 I plus 4.3373 j. After that, we will get f average equal to 0.8675 I plus 0.8675 j. For the next question, it asks us to find the magnitude of impulsive force exerted on the arrow. Based on the previous question, we can find the magnitude of impulsive force, which is using the formula, the formula. So we can just include that I and j inside the formula. So we will get the magnitude is 1.2268 Newton. For the an arrow, the kinetic energy is calculated by taking the weight in the arrow, multiply it by the square of the velocity in meter per second, and dividing by the constant 8.9075. This is the formula where we get the 8.9075. Okay, so we can include this inside the formula. So weight we know that 0.54 time with 9.81, because mass time gravity will get weight. So time with 11.3591. This is the velocity before that we get from the previous question, divided with 8.9075, which is the value that we get from this. Okay, so the final answer we will get 76.7352 joule. From the question, we can find the total kinetic energy for the work, which is equal to 1 over 2 mv squared. 1 over 2 m we know 0.54, v we get from the previous question, so we will get the final answer 34.8379 joule. For our group, we are making this comparison using two angles, which is angle 40 and angle 35. For this, still using the same concept but using the different angle. From the previous calculation, we are using angle 40, but for this calculation, we are using angle 35. From the calculation, we can see the comparison between the velocity and the time different for the angle 40 and angle 35. For angle 35, we get velocity at 10.572 meter per second, and when we substitute the v value inside here, we can get the time equal to 5.6216 seconds. So for the second question, which is maximum distance that the arrow can travel, is still using the same principle and concept as the previous calculation. We are using the kinematic equation, which is S naught plus V naught xt. So we just include all the all the answer that we get from the previous question. So we will get 49.9968 meter for the maximum distance. So we can see for when we are using angle 40, we get the value is 50.0027. But when we are using angle 35, we get 49.9968. We show that angle 40 is much accurate and better than angle 35. Then for the next question is average impulsive force. We are still assume t equal to 5 seconds. From this equation, impulsive equation, we just substitute the value V2, which is we get from the previous question, which is 10.8572 cos 35i plus 10.8572 sin 35j. So after we simplify, we will get 4.8026i plus 3.3628j. So the final answer, we will get 0.9605i plus 0.6726j. So if we make a comparison between the average impulsive force for 35 angle and 40 angle, is 35 angle force is much bigger than 40 angle. Okay. The next question is magnitude of impulsive force is on the arrow. So the magnitude, we just put this answer inside here, so we will get the force is 1.1726 Newton. So based on this, we see that the 35 angle has low force than the 40-degree angle. Okay. For the last question, it's the same with the previous calculation, and we just put the answer inside here, and we simplify, we will get 70.104 joule. For the final kinetic energy, for the world diagram, we get 1/2 mv squared, and when we just substitute all the information that we get, we will get the final answer for kinetic energy is 31.8273 joule. Lastly, we can conclude based on the equation that the higher the angle of the bow, the further the distance of the arrow can shoot, which means that it can shoot more to the target rather than low angle.